Good morning, students. Welcome to the online video lecture on the introduction part of the operations research. In introduction part, that has mentioned the LPP also, how to formulate the LPP and how we are going to solve the LPP problem by using graphical method. Here that we are going to, in this video, that we are going to discuss how to formulate the LPP problem. Okay. As you know that LPP is the one of the over technique that is deals with the optimization of function of variables known as objective function. Okay, the optimization function, either it may be maximization or minimizations, which is subjected to the various constraints. Although the entire procedure of solving LP problem compromise of all 6 phases as mentioned in the previous video lecture. Okay, what you are discussed in the previous video lecture, that is 6 phases that you need to follow here to formulate the LPP problem. After formulating LPP problem, then we need to go for solving the LPP by using graphical method. Okay, here these are the steps we need to follow to formulate the LPP problem. The step 1 is we need to define the decisions variables. These are all, we can call it as unknown variables, that is in terms of x1, x2, x3, like this. And in the step 2, to formulate the objective function. Okay, as I said that the problems comes under profit category, then you can call it as the objective function is maximization. The problem comes under loss, then the problems you can define with the minimization, the objective function. Then the third step is to formulate the other constraints. Okay, the subjected to other constraints, that is with respect to the resources limitations, market constraints. Okay, these are all the other conditions comes under. Next, to state the non-negativity constraints, whatever the x1, x2, x3 what you are going to find out in the values, those values are always greater than or equals to 0. Okay, those values what you are going to find out, so that the step 4 explains, that is the to state the non-negativity constraints, what you are going to find out the x1, x2, x3 values, those all values should be greater than or equals to 0. There should be non-negative values. Next is the basic, this one is the basic structure of the generalized formulation of the LPP. Okay, the first line is, it is with the objective function, either it may be maximization or minimization. The Z equation we can call it as, it is involves the cos c1 plus x1, that is decision variables. It involves, you need to define the objective function by taking consider with the decision variables x1, x2, x3, like this. And when the second step, when it comes to the limited resources, that you can call it as other constraints. Okay, again those other constraints also we can define with the decisions variable, that is a11 x1 plus a13 x2 plus a13 x3, like this. Okay, we can use less than or equal sign, or greater than or equal sign, or equal sign also. Okay, at the RHS side. When we are going to use those 3 symbols, I will tell you in further while explaining the problem. Okay, in the second step, that we are going to define the other constraints, that is with respect to the resources. Okay, and in the third one is where x1 and x2, as I said in the previous slide, that is always should be greater than or equals to 0. Okay, non-negative values. This is the basic structure of the LPP problem. It involves 3 steps. We need to define first objective function Z equation, next is other constraints, and third one is x1, x2, x3 are greater than or equals to 0. Now this is the first problem. Okay, this is only for the formulation. Okay, a small scale industry produces 3 rubber products. These products are processed on 3 different machines. The time required to manufacture 1 unit of each of 3 products and the daily capacity of 3 machines is given in the table below. Okay, there are three machines: machine 1, machine 2, machine 3. Okay, the product 1 he has given. Next is time. The product 1 is processed under machine 1, that is 2 minutes. Product 2 is 3 minutes, and product 3 is 2 minutes. Okay, for the machine 1, the per day the capacity is the 440 minutes. Okay, we are going to work on machine 1 up to 440 minutes per day. Similarly, he has given, that is processing durations for product 2, product 1, product 2, product 3 on machine 2, 4 dash and 3 minutes. Okay, the for the machine 2 allocated duration 420 minutes per day. Okay, now machine 3, similarly, product 1 2 minutes, product 2 5 minutes, and product 3 is nil. And per day it on machine 3 we can work up to 430 minutes. Now it is required to determine the daily number of units to be manufactured for each product. The profit per unit of the product 1, 2, 3 are rupees 4, 3 and 6 respectively. Okay, he has given the profit. Okay, for product 1 how much you are getting? 4 rupees. For product 2 3, and product 3 is 6 rupees. Okay, he has mentioned profit, so that the problems comes under maximizations, the objective function, that is maximization here. Now go for formulation. How we are going to formulation? First define the decisions variables. Okay, how we are going to decide decision variables means, here x1, x2, x3. X1 means the number of units of product 1 that should be manufactured for maximum profit. Okay, how many numbers, how many units that you are going to manufacture product to 1, that is x1. Okay, how many number of units of product 2 that you are going to manufacture per day, that is x2. And how many products that you are going to manufacture product 3 per day, that is x3, in order to maximize the profit, that we can call it as decision variables. X1, x2, x3 are the decisions variables. Now go for formulate the objective function, that is second step. The objective function, as I said, it is comes under profit, so that the objective function is to maximize some problem. Per product we are getting profit is how much? 4 for product 1, 3 rupees is for product 2, and 6 rupees for product 3. So that we can write the maximization function, z equation. We can write maximize dot z, that is equals to 4x1, that we are getting 4 rupees for product 1, 4x1 plus 3x2 for product 2, 3 rupees, and plus 6x3 for product 3, 6 rupees we are getting profit. So that the objective function is maximum dot z equals to 4x1 plus 3x2 plus 6x3. Now in the step 3, to formulate the other conditions. Okay, he has in the problem, in the given problem, other conditions are, that is with respect to time. Okay, that is with respect to time. Okay, now here the other condition is, that is he has time. 2 minutes is processing for 1 unit of product 1 on machine 1, and 3 minutes processing for 1 unit of product 2 on machine 1, and 2 minutes for processing of 1 unit and product of 3 on machine 1. Okay, that we can write for the machine 1 constant here for with respect to time, that is 2x1 plus 3x2 plus 2x3. Okay, the maximum duration how much he has given? 440 minutes. Okay, for the machine 1. Okay, the first constraint should be 2x1 plus 3x2 plus 2x3 less than or equals. Okay, less than or equals to 440 minutes, because the machine 1 works only for 40 minutes, so that maximum available is 440, so that we can write less than or equals. Suppose if it is minimum means, then we can use the symbol greater than or equal. Okay, similarly write down for the machine 2's constraints, that we can write equation 2, that is 4x1 plus 3x2 less than or equals 420 minutes. Similarly, for machine 3, we can write 2x1 plus 5x2 less than or equals to 430. Finally, we can represent the non-negativity constant, that is in step 4. Okay, as I said that for every problem x1 and x2 x3 are always greater than or equals to 0. Okay, now here you need to represent the LPP problem in the final form. Okay, the formulation, the maximum equation, that is objective function maximum is z 4x1 plus 3x2 plus 6x3. And when it comes to subjected to other constraints, there are three constraints. Okay, 2x1 plus 3x2 plus 2x3 less than or equals to 440. Second constraint, 4x1 plus 3x3 less than or equals to 420. 2x1 plus 5x3 less than or equals to 430 minutes, where x1 and x2 x3 greater than or equals to 0. Now similarly for next problem, here Gurusri Associated owns a small paint factory unit in Pune that produces both interior and exterior house paints for wholesale distributions. Two basic raw materials we are going to use, pigment A, pigment B, are used to manufacture the paint. The maximum availability of A is 6 tons a day and that of B is 8 tons a day. The daily requirements of the raw materials per ton of interior and exterior paints are summarized in the following table. Okay, the raw materials are pigment A, pigment B. Okay, exterior paint and interior paint, that is in terms of ton, that you are going to use pigment A for exterior paint, that is 1 ton, and pigment A for interior, that you are going to use 2 ton, and pigment B for exterior 2 tons, and pigment B for interior 1. The maximum available is pigment A is 6 and pigment B is 8. A market survey has established that the daily demand for interior paint cannot exceed that of exterior paint by more than 1 ton. Okay, the survey also shows that maximum demand for interior paint is limited to the 2 tons daily. Okay, the whole price per per ton rupees is 30,000 for exterior and the rupees 20,000 for interior paint. How much interior exterior paint should be company product daily to maximize the gross income? Okay, again this problem is comes under profit, because of at the last he has given to maximize the gross income. Okay, now how we are going to formulate this one is again the step 1. We need to define the decisions variables. Okay, that is x1 and x2. Okay, x1 is that is tons of exterior paint and x2 is tons of interior paint. Now again, as I said that the objective function, okay, as a comes under profit, so that maximize z equals to 30,000 x1 plus 20,000 x2. Next, third one is other constraints, that is when it comes again constraint, it is comes to raw material. Okay, for that one the we can write the x1 plus 2x2, the maximum availability is there, so that we can write the symbol, that is less than or equals to 6. And when it comes to raw second constraint for the pigment B, that is 2x1 plus x1 less than or equals to 8. And other also he has given the constraints like this: the market surveys that demand for interior paint cannot exceed exterior paint by more than 1 ton. This has to be expressed mathematically. Okay, the if x2 cannot be greater than x1 plus 1, it means that x2 has to be less than or equals to the x2 plus 1, so that we can write x2 less than or equals to x1 plus 1, or we can write x2 minus x1 less than or equals to 1. And other condition is that if other demand for the interior paint is less than 2 tons daily, it can be easily expressed as x2 less than or equals to 2. Okay, non-negativity constraints, so that there are two variables here, x1 and x2 are greater than or equals to 0. we can write the final form of LPP problem. Maximize z equals to 30,000 x1 plus 20,000 x2 subjected to constant x1 plus 2 x2 less than or equals to 6, 2 x1 plus x2 less than or equals to 8, x2 minus x1 less than or equals to 1, x2 less than or equals to 2, where x1 and x2 greater than or equals to 0. And third also, next problem he has given here ingredients A B C D for the feed 1 and feed 2 in terms of percentage. Here in this problem he has given minimum requirement. Okay, minimum requirement: if the feed 1 cost of rupees 50 per kg and feed 2 cost of rupees 30 per kg, determine the least cost blend. Here now, as I said that first we need to decide the decision variable x1, quantity of feed 1 bought in kg, and x2 is quantity of feed 2 bought in kg. Objective function, okay, here it is comes under minimization problem, so that we can write the 50 x1 plus 30 x2 minimization z equation. And third step, to state the other constraints. Okay, how much that you are going to use the ingredients A B C D in terms of percentage. Okay, that we can write in the other constraints like this: 0.4 x1 plus 0.2 x2. Here the minimum requirement he has given. Minimum requirement in the last column he has given for ingredient A, minimum requirement is 4, ingredient B 2, ingredient C 3, D is 6, so that you can use greater than or equal sign here for the constraints. 0.4 x1 plus 0.2 x2 greater than or equals to 4 for ingredient A. For ingredient B, 0.1 x1 plus 0.3 x2 greater than equals to 2. He has given in terms of percentage that you need to convert into decimal form. 0.2 x1 plus for ingredient C, 0.2 x1 plus 0.4 x2 greater than or equals to 3, and 0.3 x1 plus 0.1 x2 greater than or equals to 6, where x1 and x2 are greater than or equals to 0. Okay, thank you.